And so function notation comes in this form, and up until now, we've been kind of told that when you see a parenthesis, it means multiply, right? So we would look at this, this seems like it should mean f times x. But this does not, and it's not to mess with you or anything, that's just another way of noting a function. And they do this instead of y because as you progress in math, there are situations where you're going to be working with multiple equations. And so they'll have the f function, the g function, the h function, or any other letter that they want to do to name the function so that they all look different as opposed to y equals y equals y equals. This way we can tell we're talking about different things. Well, because it means the same as y, we can treat this as a problem that, like the problems that we were doing with our tables, where we would input the value to get our output. So if x is 2, I put in 2 for x and I get y equals 9. So I could call that, if I rewrote this as f of x equals x plus 7, then what I would say is f of 2 equals 2 plus 7. I replace the x with my input to get my value. So f of 2 would equal 9. And when we write that as an ordered pair. Again, my input comma my output. And we did that before when we were doing the tables. We'll use answers, or we'll write answers oftentimes using these ordered pairs. So here's another example of an input-output. This is an input machine. If I input x, that means I replace x with, if I input x equals 3, I replace x with 3. This is telling me to take 3 squared minus 1. And if I need to use my calculator, I can, but 3 squared minus 1, 3 times 3, 9, 9 minus 1, 8. So f of 3 is 8. That's the point 3 comma 8. So now we're going to try some using that new function notation in the problems below. If I slide this up, they give me two functions. Remember, I talked about an f function. The f function says take x, multiply it by 3, and then add 4. And the g function says take x, square it, and then subtract 6. So right here, if they want me to find f of negative 2, this f tells me which function I'm going to use, and this negative 2 tells me what I put into the function. So this is 3 times negative 2 plus 4. And again, use your calculator or use your brain. I don't really care which one you use. We just need to figure out what this equals. I'm going to do 3 times negative 2, which is negative 6, and then I'll add 4, and I get negative 2. So this translates to the point, input negative 2 gives an output of negative 2. When I put in negative 2 for x, I got the answer negative 2 as a result. So I write it as an ordered pair, negative 2 comma negative 2. In the next problem, it says use the g function this time. This just again tells me which of these two functions I'm going to be working with. This time I'm using the g and I'm inputting 4. So I would do 4 squared minus 6, or 16 minus 6, because that's what 4 squared is, or 10 when I complete my calculation. And so I would write this as the point 4 comma 10. Because when I input 4 into the g function, I got an output of 10. So the last practice one that we have there is g of negative 1. And so again, I'm using the g function, but this time I'm replacing x with negative 1. And I have to remember, we talked about this briefly before when we were working on some of our our first section. When I square a -1, especially if I'm using my calculator, I want to make sure that I put parentheses around the -1 before I square it, before I add the little 2. Otherwise, my calculator will not square the negative, it'll only square the 1, and it'll give me a wrong answer. And some of you might have seen that happen. If you do -1 squared, it shows up as -1, but it's not. -1 squared means I'm taking -1 times -1, which is going to result in a positive number. Whenever I multiply two negative numbers, I'll come up with a positive number. And that's where sometimes your calculator, although it can be your friend, if you are not using it correctly, it can also be a hindrance on you. It can also cause some trouble. So you have to please make sure that you plug things in correctly. So again, my input was -1, my output was -5. All right, so now they're changing things up a little bit. They say f of x is 19. F of x is 19. What's the difference between saying f of -2 and f of x equals -2? What's the difference between f of 19 equals something or f of x equals 19? Well, the big difference is if I don't know my input and all I know is my output, then how I'm working with this is going to be slightly different. I need to find the input. The input is the unknown part here. And so I'm going to still use the f function. The f function is 3x plus 4, but this time I'm setting that function equal to a number. So you're going to have to be aware of what's going on. Be like mindful of what the question is asking. Don't just assume if I see a function and I see a number, that just means I always plug it in. Sometimes I'm going to have to set it equal to that number. So this means I'm going to have to solve. And we've done that before as well. I know in other classes you've solved equations. In this class we've even already solved equation. How do I solve this? How do I find what x is? What's my first move? Anybody have some input? Yes, go ahead. Subtract the 4, and I do it on both sides of the equal sign. And so the 4's on the left cancel out. I have 3x equals whatever 19 minus 4 is. Looks like 15 to me. And then what do? I divide by 3. So I do that on both sides as well. And x is 5. So when I'm writing this one as an ordered pair, because I'm given the output and I found the input, my ordered pair goes in backwards. My output was what I knew, and I used that to find the input. So that's 519. We have another one here, g of x. If they change the letter, it's going to change the function that I use. So now I'm going to go back up to the top, look at what the g function is, and I'll use that to solve. So g of x equals 30. That means x squared minus 6 equals 30. And now I need to go ahead and solve this equation. So again, I'm going to ask for some help. How do I solve this? Go ahead. Add 6 to both sides. So I get x squared equals 36. This is a little bit difficult, and we're going to get more in detail in solving problems like this as we move through algebra. We're going to get some more challenging problems that come our way. But right now, I'm looking for the number that when I multiply it by itself, I get 36. And some of you, I bet, can tell right now at least one of the answers. Does anybody have an idea of what x might be? Yes? 6. X is 6. But x is something else as well. Beautiful job. X is also -6. That's the funny thing about a squared value. This little number up here tells me how many potential answers I'm going to get. So if I see a squared, I know that I could potentially get two answers, one for the positive end and one for the negative end. If I saw a cubed up here, that means I can potentially get three answers. Okay, I won't always get that, but potentially. And so my two answers are positive 6 and negative 6 for that particular setup. So that's how our functions work. Now we're going to talk next more in depth about functions. And if you look at the next page, there's a lot of writing and a lot of words, but I'm going to summarize it for you. Basically, this says, we have a soda machine. We have a soda machine or a beverage machine at school, right? And just for the sake of copyright infringement and whatever, I'm making up some soda names. And let's say there's Blast, Slurp, Lemon Twister, and Diet Slurp that comes out of this soda machine. When we think about comparing a soda machine as, or looking at a soda machine as a function or comparing it to math, we have to think about what our input is and our output is. And so can you help me come up with what is going to be the input on the soda machine? What is my input when I think about a soda machine? Anybody? What do I have to do before I can get a soda?
Put that money in.
I've got to put some money in. What else? I can't just put money in and then just stand there. Nothing's going to happen, right? I've got to press the button. Money in and press the button. Because, oops, I spelt it, bottom. Because money alone isn't going to get me a drink. Pressing the button alone isn't going to get me a drink. My input has to be both of those. What's the output? If all goes well, I put my money in, I hit the button, what happens? I get the soda. So my output is my soda. Then they give us like 3 different scenarios about what happens. And so this person, Miss Whitney, goes to the soda machine and she presses the button for Lemon Twister and she gets a can of Lemon Twister. Sounds successful, right? Would we say that the machine is functioning correctly or consistently? I put my money in, I hit Lemon Twister, I get Lemon Twister, I say yes. And I say that because she, as in Miss Whitney, got what she wanted. The input produced the output that she wanted. But then later on, Brandy goes down to the machine and she hits blast and she gets a can of blast. Sounds like it's functioning pretty good, right? And her friend Miguel is with her and he decides that he's going to hit blast. And he too gets a can of blast. Are we functioning right? Yeah, sounds good. Again, yes. They got what they wanted. The input produced one output, and that output was exactly what they wanted. And this is we're going to talk about again in more detail. I press the button for blast, I get the blast out. I hit the other button for blast, I get the blast out. Sounds good. Now later on in the day, Joe goes and hits slurp. And when he hits slurp, he gets a can of Lemon Twister. And then Sam hits slurp and gets a can of Lemon Twister. And then notices that everyone who presses slurp gets a can of Lemon Twister. Now, is the machine functioning consistently? Yes. Is it functioning correctly? No. And so consistently, yes. Correctly, no. The consistent part is that the input produced, again, one output. It was a wrong output, but it produced an output. And that, again, input and one output is a very, very important thing when it comes to functioning properly. And again, there's a difference between functioning consistently and functioning properly. Okay, so we're going to take a look at some other machines. And we have the button number for this candy machine. Now we're going to be answering functioning properly as opposed to functioning consistently. So we have this candy machine, and the first button gives me the candy called Sticks. And then the first button gives somebody else the candy called Sticks. And then the second button gives somebody M&Ns. And the fourth button gives somebody M&Ns. And then the second button gives somebody else Duds. And the third button gives somebody else Duds. So we've got these three different kind of candies. Is this machine functioning properly? What's the problem with this particular machine? It is an issue with the numbers. Yeah, what are you thinking, Nick? Right here, this guy, right? That the first one to hit button number 2 got their M&Ns. The second one to hit button number 2 got Duds. What if I really wanted M&Ns? What if it was labeled Duds in the first place? I don't even know, because they don't show us what the machine was labeled. So maybe this machine is functioning consistently. Who knows? Maybe every other one goes Duds, M&Ns, Duds, M&Ms. But is it functioning properly? And that's a no answer. And the reason that we say it's not functioning properly is because button 2 produced 2 different outputs. And again, that's a big key to remembering how functions work, or to working with functions. So let's move on. Let's check and see. How about number 2? Now we're with numbers, no machines. Now we're going into the math. In this first one, my input is that top row, and my output is the bottom row. -3 produced -3. -2 produced -3. 0 produced 4. 4 produced 2. 6 produced 0. 7 produced 6. 9 produced 10. We call this a function because each input produced one output. -3 produced -3, -2 produced -3. It's okay to have 2 inputs produce the same outputs. The key is that -3 did not show up here with a different output. So when we look at a non-functioning situation, this is not a function. And again, everything looks pretty good until I get to 2. And this is where we fail. It's not a function because 2 produced 2 different outputs. So when we're looking for our function or not a function, we have to think about it as one output for each input, or more than one for each input. So a relationship between input and outputs is called a function, and if the input and outputs behave like a soda machine that is functioning properly, we need to write down, I want you guys to write down what you think it means for a relationship between inputs and outputs to be a function. So a relationship, again, between inputs and outputs is called a function if the inputs and outputs behave like a soda machine functioning properly. Let's write down what you think it means to be a function. If you think you have something you want to share, please raise your hand and let me know. And when we're looking for a definition of a function, we are looking for the fact that each input needs to produce exactly one output consistently. We looked at tables to find functions, but we can also determine if functions or if graphs are functions by looking at their pictures. And so if I look at this first picture, I can write my inputs as my x coordinates and my outputs as my y coordinates. And if I add them to a table, I would say -3 is paired with +1. And as I move down here, -2 is paired with +3, because that's the point right here, 2, 3, or -2, 3. So -2 is paired with +3. -1 is paired with -1. Looks like no 0 on here. 1 is paired with +1. 2 is paired with 3. And lastly, 3 is paired with -2. And so what I have to do is look across the top. Are there any repeat of these x values that are paired with a different y value? If there are no repeats of the x values paired with a different y values, then we say this is a function. Now, making that table was pretty nice when it was with points, but how about if I have something like this picture, where I've got this swirl? Well, I can focus on one location, and in fact, I'll focus right here on the y-axis, And on the y-axis, the y-intercepts are paired with x equals 0. And in this particular graph, I have 0 paired with about 2 1/3. I have 0 paired with 1/2. I have 0 paired with 0. I have 0 paired with negative 1 1/3-ish. I'm just approximating. I have 0 paired with negative 3 1/2 as well. 0 is repeated over and over and over again with different output values. And therefore I say this is not a function. And in fact, one of the tricks to deciding whether it's a function or not is to do something called the vertical line test. In the vertical line test, if I can draw a vertical line anywhere on the graph and it crosses the drawing more than once, then it fails the vertical line test. So my reason for this not being a function is because it fails the vertical line test. And so anytime I see a graph that is connected like this, all I have to do is draw a vertical line. In fact, this one fails in several locations because there are multiple stops or places that I can draw, and it's going to cross the function more than once. So not a function. Let's take a look at a table again. Function or not a function. Now be careful. I want your input. Is 3 a function or not?
No.
I heard a no. Anybody?
Yeah.
I hear a yes. How many no's?
I'm going to say no.
Okay, fair enough. How many yeses? How many not sure's? Okay. Can somebody tell me why they say no?
There's a repeat of -8.
Repeat of -8. Yep. Okay. Can somebody tell me why they say yes?
Because it has the same output.
Look at what -8's going to. Does it have the same consistent output? Yes. So is this a function? Yes. I put that in there just to make sure you pay attention. Just because sometimes when we've learned these in the past, we like just look at the x's and we don't even care about the y's. But remember, the definition is that it can only go to the same number each time. And so anytime I get an output from -8, it better be 11. And if it's not, then I know that I have an issue. And so this is a function. Each input has exactly one output consistently. Okay? Let's do another quick graph. This is a graph. I don't want to make a table of all the points like I did on that other one. So I'm going to check the vertical line test. I'm going to draw vertical lines all over this thing. Vertical lines, vertical lines, vertical lines. Is there any place that a vertical line crosses the drawing more than once? No. If it doesn't cross the drawing more than once, then it is a function. This passes the vertical line test. Okay? We are just about done. We're going to sum things up, and then I'm going to have you try a few problems on your own. So we're going to sum things up. Function. What is it? A relationship. Oops. A relationship between input, typically x, and output, typically y or f of x, in which the input is paired with exactly one output. Consistently. The consistently is kind of important because we want to make sure, just because my input shows up more than once, as long as it's paired with the same output consistently, we're good. How can I tell by a table? Look for repeat x's. Make sure they go to the same output. Consistently. And how can I tell by a graph? Vertical line test. If it passes through the graph more than once, then it's not a function. Okay, so we've got just a few more to bring us back to the beginning of class, see if we remembered what we did when we started. Let's take a look at some of these problems. I'm going to have you guys talk me through it. Help me. Back at the beginning of class, what does this mean, f of negative 3? What does f of negative 3 mean? Is that f times negative 3? Nope. It's 2 times negative 3 minus 4. I replace the x in the f function with negative 3, and I simplify. 2 times negative 3 is negative 6 minus 4. Negative 6 minus 4 is not 2. It is not negative 2. What is it? Negative 10. Because remember, this is like plus negative 4. Negative 6 plus negative 4. Okay? What does g of 12 mean?
12
Then you do the square root of that. This is the square root of 12 plus 4. Okay. How do I decide which one I'm going to put it in? How do I decide where the 12 goes? The letter in front tells us. The letter in front tells us. So this is the square root of 16. What's the square root of 16?
Whole.
Whole. We've got two answers.
I say 4.
I say 4 or
Negative 4.
negative 4. I can write that as plus or minus 4. Plus or minus 4. Or I could write it as 4 or negative 4. Either one of these are acceptable. Okay, so then going on what you told me for number 8, does this mean I just put 8 in for x in the f function? No. Why not? This is telling me what about the f function? The f function is equal to this value. So 2x minus 4 is equal to 8. Now I'm going to have to solve. Add 4. Divide by 2. Hey, anytime. You are welcome. Oops. I'm going to do the same thing with this next one. That looks like that's a negative 3, doesn't it? But I don't think it is. we're going to make it a positive 3, okay? I think it was just bad, on my thing it was bad copy. So this tells me the g function, that means the square root of x plus 4 equals 3. Oh boy. Yes.
It'd be 9.
Inside of here would definitely be 9, because the square root of 9 is 3. That means x plus 4 must equal 9. Nice job. A lot of people get real confused about that. So inside of there has to be 9, so I have to add something to 4 to get 9. What does x have to be? If I'm not sure, if I can't tell by looking at it, I can just plug it in my calculator, okay? Your homework tonight is, in your packet, 1.2, I want you to do evens or odds. You pick. In the white homework packet, 1.2, evens or odds, whichever one you prefer, to show me that you got it and you kind of understand what we're doing. That's what you need to be working on now. When you are done, you can put everything away and you're done for the day. Tomorrow you will have virtual. And on your virtual, you'll just have another Google Doc like you did before, where you just have to answer some questions right on the Google Doc. It's going to be problems like 8 and 9, where you are given an input, you have to figure out the output. Okay, so that's what you can expect for your virtual. Thank you. At a loss. By this time of the day, I'm tired.